Okay, so today we're going to pull a rabbit out of a mathematical hat. We're going to look at this just brilliantly clever way to find a triangle's area. And honestly, it feels way more like a magic trick than geometry.
So picture this, right? You've got a triangle. You know how long each of its three sides are. But that's all you know. No angles, no height. So how in the world do you find the area? It's a classic puzzle in geometry, for sure. But the solution is, well, it's just so elegant. And that solution, it comes to us from way back, like nearly 2,000 years ago, from an ancient mathematician named Heron of Alexandria. And yep, you guessed it, it's called Heron's formula. And what it does is let us just completely skip over any need for angles. So, how does this ancient magic actually work? It's surprisingly simple. It's really just a two-step process. Let's break it down. Okay, first things first, we have to calculate something called the semi-perimeter. We just use the letter S for that. Now, I know semi-perimeter sounds kind of fancy and complicated, but it's really not. Semi just means half. So all you do is add up the three side lengths, A, B, and C, and then just divide the whole thing by 2. Seriously, that's it. So just to really lock that in your brain, S is the semi-perimeter. It's just half the total distance all the way around the triangle. You have to remember that S, it is the key that unlocks this entire formula. All right, now for the main event, step 2. We take that S value we just found and we plug it right into Heron's formula. So the area is the square root of S times, well, it's S minus side A, times S minus side B, times S minus side C. You see that? Our little semi-perimeter S shows up 4 times. It's absolutely the star of the show here. And this is the real beauty of it. Once you have S's, the hard part is totally over. The rest is just simple arithmetic. You just plug in the numbers, you multiply them, and you find the square root. No sines, no cosines, none of that complicated trig stuff. It's like a VIP shortcut straight to the answer. Okay, so that's the theory. Now let's see how this thing actually works in practice. We'll run through a couple of examples. All right, for our first one, let's use a nice, clean triangle with whole numbers for the sides. Let's say our sides are 7, 8, and 9. Okay, let's run the numbers. So first, we find our S, right? The semi-perimeter. For these sides, that comes out to exactly 12. Then we just plug that 12 and our side lengths of 7, 8, and 9 into the big formula. And as you can see, it cleans up pretty nicely, leaving us with a square root of 720. And when you punch that into a calculator, you get a final area of about 26.83 square units. See? Simple as that. But, what if the numbers aren't so neat and tidy? What if we have decimals? Let's try it again with sides that are 5.2, 6.8, and 8.3. Does the process change at all? Spoiler alert, nope, not one bit. The process is exactly the same. We calculate our new S value, which this time is 10.15, and then we just plug everything back into the formula. Yeah, the numbers might look a little messier, but trust me, the magic still works. And after you run that calculation, we get our answer, roughly 17.65 square units. This just goes to show how powerful and reliable this formula is. It'll work for any valid triangle you can throw at it. Okay, now before we move on, I want to point out the single biggest mistake people make when they use Heron's formula. It happens all the time. Let's call it the perimeter pitfall. The mistake is so simple. It's forgetting to divide the perimeter by 2. You get excited, you add up the sides, and then you plug that big number straight into the formula for S. But you gotta remember, S stands for the semi-perimeter. Semi, half. If you forget that one little division step, your entire calculation gets thrown off and you end up with a completely wrong answer. So you might be thinking, okay, that's a neat trick, but why does a 2,000-year-old formula even matter today? Well, this is where it gets really cool. It turns out Heron's formula is actually a super important piece of modern technology. I want you to think about any 3D model you've ever seen, in a video game, in a movie, an architectural design, whatever. To a computer, that's not a solid object. It's what's called a mesh, and it's built from thousands, sometimes millions, of tiny little triangles all stitched together. And for the computer to figure out things like lighting, shadows, and textures, it has to calculate the surface area of every single one of those triangles, and it has to do it incredibly fast.
And because Heron's formula doesn't need to mess with angles, which are actually pretty slow for a computer to calculate, and instead just uses basic arithmetic like adding and multiplying, it is blazing fast. Game engines can use it to just tear through area calculations for thousands of triangles every single second. So yeah, that ancient math from Heron of Alexandria, it is literally powering the 3D worlds you see and play in every single day.
And that really makes you wonder, doesn't it? Heron's formula is basically a 2,000-year-old math hack that just so happens to be perfect for modern computers. So what other ancient tricks and shortcuts are hiding in plain sight, powering all the technology we use without even thinking about it?